All right, introduction to the Raspberry Pi Pico. And I hope that you just remember, Ed here, I borrowed this from him. If you like this program, you fall asleep with your head like this, okay? You can go, we're getting about that time of the afternoon. You can even snore, just do it quietly. Now, if you don't like this program, you just sort of go like this. Now, at the end, if all the heads are forward, I'm okay with that. Got that from Ed here, who is no longer at the ARRL lab. He finally retired. But I borrowed that from him 20 years ago and have used it ever since. All right, we're just going to do a brief overview today of the Raspberry Pi, where the inspiration for the Pi Pico came from. And we're going to talk about a little bit about the Raspberry Pi Pico and then give you what you need to get started with it. And then some Raspberry Pi Pico resources. This will be on the section website between now and Monday when I have the, after I get home and get a chance to turn all the links on. I got to upload this updated presentation and Mike's as well, because I know he revised it, that presentation as well. But at least this will get you acquainted. And I was hoping to have a demo, but it didn't. And I did it on a MacBook, believe it or not. I actually got the thing to download. I've got the Thorny running, downloaded code to it. For some reason, the LED didn't blink, and I got to find out why. So it could be the board itself. I might have popped it with some static electricity, and that might be why. So I'm probably going to order another Raspberry Pi Pico and see if the results are the same. All right, let's talk about a review of the Raspberry Pi itself. You know, computers used to have large printed circuit board layouts and took 50 to 100 watts of power. That was common when a lot of us got started. How many were in PCs and computers in the 90s in the room? Probably a fair amount of hands. Almost all the hands went up. And I even back around 2000, I explored the possibility of building a repeater controller from a PC motherboard. And it was quite a challenge. But the Raspberry Pi changed all that. How many of you remember the original Pi when it was announced in QST magazine in 2012? Remember reading in what used to be called the Strays column? They had it was a little tiny announcement on a page of QST in 2000, I think March of 2012, April, somewhere around in there. Hard to believe it's been 12 years ago. This little computer for $35, and that was quite an attention getter at the time. Look at the capabilities that the Raspberry Pi 1 had. You could buy it without Ethernet for $25, or you could spend $35 for an Ethernet connector. It had a single core ARM11 processor. It only had one core. That was it, just a single core. 256 to 5 meg 12 megabytes of RAM, had an Ethernet port and an HDMI port. I watched an interview on YouTube with Eben Upton, the developer of the Raspberry Pi. How many of you have heard of the BBC Micro? You ever heard of that? Maybe some of you have. It was a computer built back in the 80s for kids to teach them how to do coding, how to do programming. And Eben said to him, he was remiss there wasn't anything like that around anymore. And so he said, I wanted to come up with a computer that the young kid at home, middle school or high school student, could play with their computer by using mom and dad's television. And by then, HDMI television had become ubiquitous, even that far back. Had supplanted it. My first computer, and I'm going back down memory lane now. I remember the Commodore 64 or the VIC-20. Oh, now a lot of hands went up. I remember I was an Atari guy. We didn't like commode doors. So yeah, that's what we called the Commodore. We called it the commode door. But I was an Atari 800 XL guy. But they used an ordinary television. You had this, I saw on Facebook a picture recently, this little switch box. And we remember what it was. The old had the slider on it. It had a 300 ohm twin lead output. Now, the folks actually had 75 ohm F connectors that were cable ready, just had the balun on the inside, was all it had. You know, you had to come up and put a balun on the outside, but it had a 300 ohm twin lead connector. You connect up to your television, one went to your computer and one went to the outdoor antenna. So you switch between the antenna, you put the TV on channel 3 or 2, and now I'm really going down memory lane now. And then your computer could display on your television. Well, Eben Upton remembered this and developed the Raspberry Pi to have an HDMI port. They could use mom and dad's television to start coding. And it had USB ports that only had 2, and it was only 2.0. Now, for the time, That was quite advanced. I mean, we're talking 12 years ago. Uh, I actually built an APRS portable station in my very first Go kit, 2014, with that, and got it to work. I got it. I ran what's that APRS? A client that runs on Linux. Now I can't think of the name of it, but I got it to work, and it worked pretty well with a Raspberry Pi 1. But it was the start of things to come. And there is a picture of the ubiquitous. By the way, if you got one of these, I've still got two. You got a collector's item now. And who knows, maybe they're worth some money before too many more years. But the Raspberry Pi 1 was a great start. Well, we had the Raspberry Pi 2 that came out around 14 or 15. The Raspberry Pi 3 came out after that, and the 4. Now, the 4 was one that came out in 2019 that really got into modern times. It had an ARM Cortex A53 processor. It was quad core. I believe the Pi 3 or 2 was dual core, if memory serves me correctly. I've included a link here in the slide. You can go back and look at the specifications of the Raspberry Pi 1 through the 4. It gives you all the specs right on a nice little chart there. It goes to a website, and I've included that link for you. But the original only had 512 megabytes of RAM, and I bought one with 512. I made sure of that. 1 to 8 gigabytes of RAM. Now that's getting more up in our modern computing area. Bluetooth and wireless networking capability were introduced with the Pi 4, I believe it was. And then they switched from the one HDMI port to 2 micro HDMI ports, so you could have 2 monitors. They were trying to compete. I'll tell you, the Raspberry Pi Foundation and even Upton have really tried to make this computer good. And they introduced also in the Pi 4 USB 3.0 ports. That was another new thing that came out at the time. And there's roughly what it looked like. It went from having 2 to 4. I think that Pi 2 and 3 had 4 2.0 ports. It was 3 or 4 that introduced the 3.0 port. You can see there the micro HDMI ports. They also on the 4 went to a USB-C connector. It needs more power. How many remember in 19 when it came out, they had a fault on the Raspberry Pi 4 that some USB-C, some power supplies wouldn't work. Some of you may remember that. And so you had to have their power supply or one that you knew would work with it. And then they fixed it in future production versions, and that problem went away. It was the way they laid out the C power port in it. But quad-core processor, they made a lot of improvements. Now, the Pi 5 came out last year. It was another jump. They went up to even a more powerful ARM Cortex processor. The previous version had the BCM 2711 in it. They put in the BCM 2712 by Broadcom, and it had an 876 processor, 2 to 8 gigs of RAM, Bluetooth 5.0 on this version, 802.11 ARRL protocol, still the Micro 2 HDMI. Now, some 2 new features they introduced in the Pi 5. PCI Express port. Does that ring a bell what that does? You can have an SSD drive on one now. That is new to the Raspberry Pi 5. Also, a UART port. How many familiar with UARTs in the room? I know several of the hands go up. UART is the protocol for RS-232 serial ports. And of course, they added an on-off switch on the Pi 5, which was quite nice. You could turn it on and off. And it has a cooling fan port. You don't have to have an add-on and tap into the headers anymore. They actually got a connector on the board where you can plug a fan in now, which is really, really nice. It retained. I'll get to the picture in just a moment. There's the links for the Raspberry Pi 1 through 4, full specifications. You can take a look at them. And Raspberry Pi history. I included those links. I should have put that slide next. This was 11, almost midnight last night when I was finishing this up. You can see now if you're the current Raspberry Pi 5, it has a little bit different look. Notice it's got 2 DSI connectors on instead of 1. And notice the addition of the PCI Express bus on the left side. Now you could do SSD drives with it, which is really, really cool. On-off button was added. It also has, again, it retained the 2 HDMI micro ports. It also retained as well the 2 USB 2.0 and 3.0 ports. It kept that from the previous, but it was an improved Raspberry Pi 4 with a hotter processor. And you can see the heat sink there on the outside case. It gets a little bit warm. This one, I think they recommend you fan it. I mean, it gets quite warm. But that just shows you how far it's come in just 12 years' time from that little article in QST. It was in the strays, like the corner, it was a bottom corner of the page. It was about that much of the page that mentioned the very first one. But now it's become just ubiquitous in the ham world, and it's taken off. There's a company making amateur radio repeater controllers out of these. I saw them in Orlando Hamcation. You can make a lot of stuff, weather stations. You mean, your imagination's the limit. Now let's take a look at the Raspberry Pi Pico, what that is. Let's just introduce that concept, what that is about. The Raspberry Pi Foundation also produced and it was mentioned, I believe, by Gordon today, a Raspberry, the Raspberry, oh, come on, it just went out of my head. A miniature Raspberry Pi Zero, that's it. The Pi Zero, it's about this long, about this thick, and I didn't know they were running the S-Bit-X with that thing. Somebody actually tried it and it worked. It has a lot less, I think it's got like 180 milliamps of current drain. The original Pi had like 500, 600, 700 mils of drain, 800 mils, something like that. But the Pi Zero had like 180, and they actually ran S-Bit-X radio on it. So, by the way, that was great on the improvements on the S-Bit-X. I can see it's really matured a lot. I still want to tinker with mine a lot more, but it's the ultimate tinker's radio, and you can play with that one while you leave your 7300 up for nets or whatever, and you can play with the S-Bit-X radio without any trouble. But in January 2021, not to be outdone, they're constant innovators at the Raspberry Pi Foundation. They produced their first microcontroller chip standalone, the RPI 2040, and I included the data sheet for that link in the description. One thing I like about the Raspberry Pi Foundation, Gordon will tell you this, he's been there enough times to read, I'm sure. They have excellent documentation. raspberrypi.org. I think that's the main URL. You can look it up right now. That's okay. When I'm in church, a pastor gives a reference, I look other places. You could do that too. That's perfectly okay if you're on your smart devices chasing a rabbit. I don't mind that. But and this was their first standalone microcontroller chip. And why did they pick that name? RP stands for the Raspberry Pi. 2 is a dual core processor. The 0 is an ARM Cortex M0 processor. Now, in the ARM line, which stands for Advanced RISC Microarchitecture, the ARM the architecture is developed by a company in the UK also named ARMS Holdings Limited. But they don't build the chips. They simply develop the architecture. They license it out to Texas Instruments, ST Microelectronics, Microchip don't build. They have their own 32-bit architecture. But these are 32-bit processors. And they license out probably about 10 or 12 different semiconductor manufacturers. And when you buy the chip, you're paying part of the license fee to ARMS Holdings Limited. But they developed the architecture. In the Cortex series, you have A, M, and R. A is the higher end processors, like in smartphones. Smartphones use an ARM Cortex A processor. As a matter of fact, the A76, I think, was used in some smartphones, if I'm not mistaken. The M series are the CPU speeds are about 700-800 megahertz a gig. I think on the A76 is 2.7 gigahertz, something like that. But the ARM Cortex M series are slower speed. It's for things that you don't need a graphical user environment. You may have a screen that may just have a simple display on it, or something like that, or just with LEDs on it. You don't need a high power processor for that. You buy a processor depending on what your needs are, what kind of project you want to build. And the 4 stands for the amount of RAM, and 0 stands for the amount of program memory. So the one drawback on the RPI 2040 microcontroller, it's got 264 kilobytes of flash RAM, but it has the chip itself. This is where it destroyed my presentation last night. It has no onboard program memory, no onboard flash RAM on the chip itself. It has to be external. That was the way they developed it. Many modern microcontrollers on the market, they got program memory, flash RAM, and then they got scratch pad, that's static RAM that's separate. Static RAM's for your data variables while it's running. Flash RAM is for your program memory. Well, they didn't put any on the RP2040, but they did give you some nice features on that chip, a USB 1.1 port. You say, wow, USB 1.1. Well, for small devices, that's all you need. If you're just having simple low-speed data or low-speed inputs, you don't need anything else but a 1.1. Remember, this is not for a high-end smartphone. It's not a high-end application. This is for embedded applications. It has 2 UARTs, 2 SPI, and 2 I2C. Now, how many of you know what SPI and I2C is? I know Gordon does, a few others. SPI and I2C are serial standards in the microcontroller world. Chips and so forth either have a SPI interface, that's developed by Motorola. Serial Peripheral Interface is what it stands for. And then I2C was developed by Philips Semiconductor, which today is NXP, I believe, NXP Semiconductor today. That was each, and I've heard for years, SPI versus I2C, which one is better? Well, it depends on what you're doing. And mainly it depends on what peripheral you picked. That is what port you use. SPI has its advantages. I2C has its advantages. And of course, it has 16 pulse width modulated channels. Pulse width modulation would be you could make an LED glow brighter or glow dimmer. That's one application of pulse width. And if you have a smartphone and you can turn the intensity down on the lamp, it's done with pulse width modulation. They take that square wave and do the duty cycle less, which you could do in software and make it dimmer or make it brighter. And of course, the Raspberry Pi Pico has an onboard temperature sensor. That was a little feature they threw into it. And there is the Raspberry Pi Pico specifications. The link will be included in the slides when I get them up on the site, and you can download them. And there is a layout. Notice this multi-port. Now, I'm sorry you can't see it. Oh, it turned out pretty good. It's got general GPIO pins, which you can, they also double SDA and SCL, that's I2C pins. Let's see, let's go over to this side. I'm looking for the UART. You see your UART pins there? That's for a standard serial port. Depending on how you configure the controller in software, determines the function of that pin. There's what called multifunction IO pins. It could be a general purpose IO port. It could, if you configure it, that SCK and SCN, that is a SPI standard. So the purple, and it even color codes it over here for you. If you set it, that is a SPI port, depending on how you configure it in software. If it's blue, it's an I2C port. Again, you can configure the device to do two SPI ports, one I2C. The other way around, you could configure it to do 1 or 2 UART ports, whatever you like. It's entirely up to you as the designer how you configure it. And there is the 4 variants of the Raspberry Pi Zero. And there is mine. That's how big we're talking. You say, that looks familiar. You're right, it does. It's a 40-pin dual inline package, dip header. You could, if you say, I'm not good at surface mount soldering, that's okay. You've got a header on there. You could solder that onto a printed circuit board and make your own project out of it. They put that on there for you. And the cost is an expensive. You paid more for the pizza today you ate than you would have that. The cost of this is $4. $4. You can throw them away almost. I mean, people waste more money than that in a soda machine in 2 days than they do on a Raspberry Pi Pico. Now you can see the 4 variants up there on the screen. The one on the left is the standard Pi Pico without wireless, 802.11. And the next one is the Raspberry Pi Pico H. It has a serial wire debug connector on it. Notice the connector. That is a debugging standard used in microcontrollers for in-circuit debugging. So in other words, you don't have to pull it out of circuit and put it in something else. You leave it in circuit, and that serial wire debug protocol, I've never used it myself, but it'll help you. Now, but you could use it yourself. And you see the next 2, notice they got that little shield right there you could see on the chip. That's the wireless transceiver. That's an 802.11 transceiver IC. It's got a shield over it. And one is without the debug connector, and one has it. You can see it. It's not soldered onto that one. It's soldered onto that one. And I bought the one, I think, without the serial wire debug, but mine's got the wireless option. And it's just, you can get them whichever way you want. In my opinion, you might as well go ahead and buy it with a, unless you have to worry about current limits or something, buy it with a wireless option. Because then you can build a project and it can connect to your wireless access point or to send data or something. Okay, just to get started with the Raspberry Pi Pico, very easy. You need three things. You need this. Need and by the way, Raspberry Pi Pico development environments will run on Windows, MacBook, Kyle's smiling right now, or Linux. I loaded Thonny on my MacBook and got it to work. And also, there are several development paths. Now, Thonny is what is recommended by the Raspberry Pi Foundation to start with if you're new at Python programming. It was Python for beginners, but you can use Mu Editor. That's another one out there. I'm evaluating that. And that's in Windows and Mac platforms because I downloaded, got it to work on my MacBook. And it's Kyle's fault over here. He mentored me in Apple, and I mentored him in ham radio. So, but he ruined me and got me into Apple big time. So now I'm an Apple enthusiast now. I just wish they were open source. That's all. But I mean, he said he ruined me for the better, and he's probably right. But I've been my old 2017 MacBook. I love it. I even got VMware Fusion Player. That is the Apple equivalent to VMware Workstation for Windows. I'm running Windows 11 as a virtual machine and Ubuntu Linux on my MacBook. Some of my applications run better in Windows than they do on Mac, so I run them on my virtual machine on my Mac, and I love it. So I just wish the icons sometimes were bigger, especially when you get older, hard to see. But I didn't think I'd like Apple as much as I do, but I do. I just wish they were open source. But anyway, you need a micro USB cable, and you saw one a while ago. Everybody knows what a Type A micro USB cable looks like. You need that, and you need a Raspberry Pi Pico. Three things. That's all you need to get started experimenting. Now, I'm going to see if I can make this video come up here. And it'll show you how to use Thonny. It's about 5-6 minutes long. No, 7 minutes. I'm sorry. And he does an excellent job, this guy here. It's just how you get started on the Raspberry, how you install Thonny and how you run it for the first time. Let's see if this is actually going to work. And yeah, maybe.
Good news for those following on a Raspberry Pi at home. You already have Thonny. For me, I'm running Windows today, so I'll need to download Thonny. Navigate to thonny.org and choose the version.
See the Mac version in Linux?
This folder. I can see that Thonny is downloaded. I'll run the installer. Normal installer stuff. Great, let's run Thonny. Time to find out Pico, and my Pico has pins on it. Is it okay if yours doesn't? That one make a difference for now.
You can buy it with and without headers.
And to your computer through the USB cable. Go to Run and select Installer. And make sure that you select Micro Pi and Raspberry Pi Pico. It's also a good idea to install or update the firmware first. One last thing that makes life a bit easier is to go to View and Files. And this will show us our file tree on the left. So we have the local files on our computer and the files that are on the Pico. And we are ready to go. I have the REPL down at the bottom here. So this is the interactive Python REPL that's running on the Pico. We can actually execute some live code. I can say print hello world, and the Pico will take that print command and send it right back. The REPL's great.
See, REPL mode is where it communicates with the Raspberry Pi Pico, and the Pi Pico then prints back to your console. So you know it's running.
This complement here is our empty untitled script. First thing is to import some packages.
I think that's where my demo bombed.
This will give us the ability to control the pins on the Pico. I'll assign LED to pin 25. That's the pin on the microcontroller that the LED is connected to. We call that the output. Now, if we create a loop set by a while through, we can toggle that LED. But if we were to just execute this, the LED would turn on and off so quickly we wouldn't be able to see it. So we need to include a delay. We can say from time import sleep. And we can then use the sleep function to create a delay of, I'm going to say half a second. We can save the script and save it to the Raspberry Pi and call it main.py. If all goes well, you should see on your Raspberry Pi Pico, there is a new file called main.py. The file isn't actually executed yet. For that, we need to restart the Pico. From that REPL interface, you can press Control D. That's called a soft reboot command. And now that the Pico has booted up, it's going to look for that main.py file and run it.
See the LED on the board blinking?
It's flashing. It's often useful to print text to the screen when you're programming so that you can do some debugging. So let's do that now. I'm going to create a number n and set that to 0 for now. And now, after toggling that LED, I can execute a print command and say that 13 times, and now we call upon a variable n is some other variable. What is the quotes and open format function? So 13 times n, so we put n as our first entry, and then 13 times n as our second entry. 13 times n. Perfect. So the order that you put arguments in here will matter. The first argument will go in this first place, and the second argument will go in this second place. And finally, we just need to increment n. N equals n plus 1. Save that file again, and Control D for a soft reboot. And there we have it. We have a blinking LED, and we also have some nice printed commands coming out on the screen. So this is a neat way to print the values of variables to your console so you can see what's going on. There is a pretty cool feature as well, where if you go to View and Plotter, you actually get to see a plot of various things that are happening in the Pico. So down the bottom here, we have the key to see this. Blue times orange is red. So it's picked up on our print statement, but it's actually extracting information from it. We can see that this line here is slowly increasing in value, and right now it's over 1,000. So this is corresponding to the result of our multiplication. At the moment, it's nearly 1,500. And we have this orange line here. This would be our n, because we have 13 times n. And we can pick that out of the argument as well, because it's actually showing us our print statement. So this is really neat. Looking back at our file tree, we can see that main.py is on the Pico. So if we disconnect the Pico and then reconnect it, we can see that back in Phony, the Pico was disconnected, and also that file tree window has disappeared. Even though our Pico was running our script, to have it appear back in Phony, we just need to use the stop restart function. And now we have our REPL again, and we can see our file tree. However, this doesn't mean that our Pico has stopped executing its code. But we can just start it again using Control D. So we've been saving our scripts directly to the Pico so far, as you can see in the file tree here. If you want to create a backup of that on your computer, you can right-click and select download to my user home directory, and then you can put it wherever you like. Also, the scripts that are on your computer already, you can right-click them and select upload to, and that's the root directory symbol. So that will upload it to your Pico, and you'll get a warning that it's going to overwrite the same file on your Pico.
And with that, we are on our way to programming the Raspberry Pi Pico using MicroPython and File. I hope you learned something. I know I did. If you have any questions remaining, feel free to open the thread on the Core Electronics forums. We're full-time makers and here to help. Catch you next time.
So what, you said it kind of quickly, what kind
Yeah.
of programming language is it?
It is called Python. It is an interpretive language. Well, I thought I stopped it. I guess it was one of those. Now I'll show you a really neat whole series on there that I happen to like. And I'm going to include these in the slide presentation. This guy right here, Paul McWhorter. Okay, get through the commercials. He does the graphics, puts the screenshots in for you and everything. It's a whole series. He was only up to lesson 7 or 8 last time I looked at it. But yep, he said, and he has series on the Raspberry Pi, the Pi Pico. I mean, he's got all sorts of series on his YouTube channel. It's called Paul McWhorter, Arduino R4 Wi-Fi lessons. That's a new one I didn't know. He's got some interesting. He always has that tropical look in his background. So there you go. Let's go to playlist. I'll let you see that. Raspberry Pi Pico lessons for beginners. He has that series. Fusion 360, Raspberry Pi, the big Pi tutorials. Python, you can learn Python there. Oh, he's put a whole bunch on there since I've looked last. But he always has some very, very interesting. He started out with the Arduino, and now I'll put Paul McWhorter's on the slides too as well, so for your benefit. But what's nice about the Pi Pico, it is so well documented at the Raspberry Pi Foundation website, raspberrypi.org, and so is the regular Pi. The Pi Pico, it's all very, very well. And you can see how easy it is. You program it with a USB cable. First, you load your you load the bootloader to it when you set it up, and you saw in the video where he walked you through that. Then you simply dump the code to it and run it. It interprets it, and you stop it, edit it, and redump it to it and run it. It's a great tool if you're new to programming. Python is sort of like the basic of today, basically. It's similar to basic language now, but it's it's a little more forgiving on variables, how it handles it. You could when we had the code up here, let me see if I still got that or not. No, I don't think I do. But you saw there with the import commands, he was importing Python libraries. He was calling on those libraries, but you have to import them to call on them. That's a wonderful thing about Python and C++. They are object-oriented languages. In other words, you can one object can call on another, and that one can call on another object. If you change the programming in this object, these two don't have to change because it's like redesign the tool. The interfaces are the same. You can add an interface too, for that matter, but your existing code don't have to change when you update an object. That's a wonderful thing about object-oriented programming. Let's reopen our slide presentation now. Okay, let's see him at the bottom here. There we go. Yes, I know about that. Yes, you destroyed my presentation. Oh, Microsoft. I'd have my MacBook, it wouldn't destroy it. Did I just say that? Okay, let's start from here. If I can. From current slide. Okay, there we go. Okay, let's go back to that. Resources for the Raspberry Pi Pico. I put links in the program description for you about it's the Raspberry Pi Pico homepage, has full specifications, and again, they are very well documented. They did a really, you've seen some products out there that the documentation is so-so, like some of the Chinese radios we have. They're scant, or the Raspberry Pi Foundation, they've done a good job documenting things. This will be in the slides. You'll be able to pull them down. They will be hyperlinked. You'll just be able to click on them, and it'll take you right to the web page. Program, by the way, you could program the Raspberry Pi Pico from Visual Studio Code now. You can do it from that. And that also runs in Windows and Mac. Does it run on Linux as well? That's the part I don't know. I think it's just Windows and Mac it runs on. a Visual Studio Code. Well, it wouldn't matter. I just run it in a virtual machine. So there you go. But yeah, I see I made a mistake there on the link. I got to fix. And I'm going to recommend something to you if you develop. You see the picture up there? Get you one of these little breakout boards. I have in my truck, I built an actual full microcontroller development station, but you can see, and I'm going to show you right here, this Raspberry Pi Pico will seat right into this. Right there. I didn't put it in all the way, but it allows you to play with it. You can power it externally from here. By the way, a caution on the Raspberry Pi Pico ports. Like most modern microcontrollers, don't put over 3.3 volts into it. Some controllers only handle 1.8. That's modern microcontroller design. So if you use the ports, you have to buffer them. And if it's a device that has like 5 volts, TTL voltage levels, you'll have to have a buffer chip. It will not like it if you go over 3.3 volts. You could damage a microcontroller. So you can see it breaks out the headers for you to use little jumper wires and go to a breadboard and interface other chips to it or display or whatever you want to interface to it. You can then experiment without ever soldering. That's the advantage of it. You could get you a little breadboard, get the little jumper wires to go over into it. Now, you're thinking you're not designing anything high frequency, like Gordon talked about today in the S-bit-X. They didn't drop in enough caps in places, and it actually produced spurious oscillations that were not supposed to be there. The original S-bit-X had a problem. It destroyed the finals through VHF parasitics, and they've gotten through that and have resolved that since then. But it's good. At this board, by the way, you're going to like this. You can buy it on Amazon for $10. It's dirt cheap. Amazon, and you can search that there, Keys. No, I didn't spell it right. It should. Well, I did. Keys Studio Raspberry Pi Pico IO Shield. It's the Raspberry Pi equivalent of an Arduino shield, but it's a breakout shield. And notice on the board there, you'll see it on the screen. I'm going to pull this off so you can see it. They do have a voltage regulator on here for power. If you put it in that DC power jack, that's a 3.3 volt regulator. You can see it right there in the middle. And there's some filter caps on it as well to keep down parasitic oscillations. And then when you design circuits, you have to run analog ground and digital ground. You got to be very careful. On these modern chips, you can get some VHF, UHF parasitic oscillations if you don't. But when you're breadboarding, you're probably not going to be worried about that too much for the purposes of this. But if you start getting up in the megahertz range, you got to be concerned about that. Length of your wires can add extra inductance and capacitance, and it can become an oscillator when you didn't intend it to. Now, I guess the important part, questions, comments. I'm not the expert, but I'll get you started in the direction. Yes, Gordon. Yeah, the Pi 2W. You mean assuming you can find one? Huh? Now, Adafruit and SparkFun, I think, are the distributors in this country. Well, the Pi W is the Raspberry Pi Pico is much lower in capability. It's a Cortex M processor. If you want something that don't quite have the horsepower of a full Raspberry Pi or a Raspberry Pi Zero W2, a Raspberry Pi Zero 2, I think it is. I think you must have the second version out now. You may have something that don't need a lot of horsepower, and something therefore draws a lot less current. The Raspberry Pi Pico don't draw nowhere. I don't even think it draws 100 milliamps of current. Probably draws a lot less than that. Look at the header and look at the size of that voltage regulator. It probably don't draw more than 20, 30 milliamps, maybe 50 tops. I should have looked at the specs on that to see what the Pi Pico itself in there, but it'll be in the specification sheet. But the current draw is much lower. So if you need something for an embedded application that needs wireless connectivity, the reason they made the version without it is without the wireless transceiver, it draws less current. So if you need something like gather a weather station, you should be able to build a weather station that parts data to the outside world with that. It's only pulling data from a few sensors every few seconds. There's plenty of horsepower in that. You could make it run a basic OLED screen. You could use that Pico, I would imagine, to control QRP transceivers. If all you're doing is moving the frequency and need a display, and it would have more than plenty enough horsepower for that to run a simple QRP radio or something you want to homebrew. That's where it has an advantage. Now, there is the STM32 blue pill that's based on an STM32 F103 controller, and it's about around the same price, but it has a lot more horsepower. But where it's limited, and what's nice about the Pico is the amount of support out there for it. There is more support than there is for the blue pill, and I'm not putting the blue pill down. It's a good device. And again, I think they're about $4 or $5 also. And you can buy this. I bought mine with headers. You can buy it without headers. You can buy it just with through holes in the board. You can buy it that way as well. So any other questions? Yes, sir. Zero. Probably, I would say that's about right. I'd say it's about right. I think it, and the W would mean wireless. You could buy the two, just the 2 and then the 2W. So yes, it does. It has a micro HDMI connector, I believe. Maybe it's a mini. I can't remember which one. Yeah, Adafruit, and let's go back and compare them. It's a little old, but that's okay. Let's go here. Hopefully this will work, maybe. Yes, I want to open this file. And now I got to come out of presentation mode. All right, let's do this and stop presentation mode. And that, and that, and there we are. You can see there that compares the, I don't think the Pi 0W is in this comparison. But that's the product data overview chart. It's a little bit dated, but it tells you the first 3 Raspberry Pis and what their capabilities were. So you can see the evolution of how they improved. But the Pi 0W would have it like in running the SBITX. Yes, it's got enough horsepower to do it. And so, hey, if you want a lower power SBITX, that'd be the way to go. Or if you want to incorporate it in another case, which you can. That's what I like about the UBITX. Now, how many of you heard of the UBITX, the predecessor? It's an analog transceiver. The SBITX is an SDR radio. The UBITX, and I actually have one right down here. I'm going looking for another one of those where my job gets in the way of my hobby. Yeah, Kyle and I are frowning both because ours get in the way often. That poor guy starts before I do in the morning and goes till after I do usually. But some days I feel like it all comes at me like it comes at him. But you could use this right here to do special things with it. I mean, you could use it for a sound card interface, control a sound card chip or something. I mean, the applications are limitless. It don't need a lot of horsepower, therefore don't draw a lot of current. So it's a niche processor. It'd be like a PIC microcontroller, a high-end PIC, maybe a 16-bit. And yeah, I still like PICs, don't get me wrong. The RSGB has an excellent book, and I have a copy of it over here. There's their microcontroller book. They talk about the STM32. They talk about the PIC microcontroller and the Raspberry Pi Pico, I believe. Yes, sir.
Different Raspberry Pis are wireless, and what flavor of wireless?
The Raspberry Pi, I believe 4 and up had wireless options. The Pi 0W, W meant wireless, and the Raspberry Pi Pico W also means wireless. Look for the W. That tells you it has the wireless. And what matter of fact, that I think, if I'm not mistaken, it may have went back to the 3. Okay, it was the 3B. That was the first one that had the wireless transceiver. I kept thinking it was the Pi 4, but the Pi 3, yep, it had that little shield on it. You look for that wire because it's a shield for your transceiver. Remember, you're talking about something that generates 2,400 megahertz. Better have a shield over it. Oh yeah, 802.11 is the standard. There's A, there's B, C standard, N. B is legacy. A, C, and N are still more modern. And A, I think A is N, and let's see, I think C is a different band, if I remember correctly. I can't remember the standard specifications at the moment. It was 802.11. You have an A specification. B is legacy now, as they call it in the industry, as the industry standard for obsolete. Yep. Yeah, that's the I think that's the C standard is 5.8 gigs. And because you have 2.4 that depending on which standard you run. I mean, the standards are all published. You can go read and find out about it yourself. But they tried to make the Raspberry Pi where it was 2.4 gigahertz, 802.11 capable. So you could connect it, because the truth is, you've heard of the concept, the Internet of Things. John, let's see, Pellant, W1JP, has done workshops here for us in TechCon. I want to get him to come back on doing Internet of Things, taking a device. He actually had it set up to read room temperature and send it to a website, all from his device. He showed you, he actually did a hands-on live demonstration. And he likes to use JSON objects and so forth. And somebody got a hand up? Oh, okay, I'm looking at the screen there. I thought somebody had a hand up. Okay, well, at this point, let's see. I guess I'll do this for what it's worth. And let's see here. I'll just put this up on the screen, because if there are no more questions, now go and experiment. No matter what it is you experiment, go and experiment with something. We as ham radio operators, we're that 3% in this room that likes to get our hands on hardware and experiment. Developments and things like NXDN depends on those of us that experiment in back rooms. And I encourage you, find something you're comfortable with and experiment with it. Dig into it and tinker. Hey, if you do wrong, you learn what you did wrong. I mean, what did Gordon talk about in his program? How many times he blew up Raspberry Pis till he got something right? Well, he learned and was able to share that with you. So go and experiment. And at the end of the slide presentation is my contact info. I'm going to put this slide presentation on my personal website as well. So if nobody else has any questions, let's give out some door prizes. We didn't do that today. I was so focused on the presentations that I lost track of what we were doing here. So if there are I don't see any questions online. So we are going to terminate the stream online at this time. I get to my mouse here. There it is. We'll hand out what little door prizes. I did that. Okay, and here we go. Oh, yeah, sure. As a matter of fact, we're going to terminate the live stream here and have a little discussion about some ideas for future TechCons as well. Anyway, thank you very much for those attending.